Hey guys, welcome back to the channel. My name is Zahir and we're going to keep this video very short because this is explaining a concept and essentially sharing my opinion about specific learning that I've had in the recent weeks. So let's dive deep into the theme that I'm going to talk about. So today's theme is essentially tools first approach to building reliable AI agents. Okay, I'm going to expand on that particular thought in a bit, but let's talk about the use case, as something that will essentially explain the idea on, right? So let's say that you've been given this use case at work. Okay, your task is to essentially build an email processing agent that can read emails, understand the emails, route it to different the appropriate tasks depending on the kind of intent of the sender was, and execute those actions or tasks by hitting those relevant tools and responding back to the user. Okay, uh, these might look simple, but they're very complex because you'll have to be 100% sure of what are the kind of responses that you want to send back to the sender, and obviously the intent has to be right. You're able to extract the relevant information, and if any other information is missing, you need to ask for that information from the sender, right? So these look simple at the outset, but these are relatively complex depending on the complexity actually that you're working with in your processes. Okay, but let's assume that this is the use case that has been given to us. Typically, how would you solve this? And there are two ways, right? You would probably use a framework. Let's say that you're using two popular frameworks, right? Maybe you're well versed with CrewAI or LangGraph. If it was CrewAI, you would essentially establish the task, right? Even before you do that, maybe you have a habit of illustrating the entire flow, start right from the intent to the relevant, you know, workflow or sub process being called. You illustrate that on Visio or Figma or anything, so that you have a full visual flow of the entire, you know, uh, entire problem that you're trying to solve. Right now, with CrewAI, you would basically break it down into different tasks that you're solving and your agents supporting, and then you write those flows. Right, you either write the flow or you write the tasks. Or you probably create a crew of agents. Let's say that you're creating crew of agents, three agents essentially. The first agent is the invoicing agent. Let's call it invoicing agent, where you are essentially building a task or a flow to classify the incoming email and then call the relevant tools and then generate a response. Same goes to the other two use cases, correct? Maybe that's one of the approaches. But if you're using LangGraph, maybe you break it down into multiple nodes, or you break it down each task into multiple nodes again, where each task becomes an agent, and each agent has multiple nodes, edges, and tools. The tools probably are similar, like in the invoicing API or the email client. Okay. Now, what is the drawback of this, right? These tools, for example, CrewAI actually talks about how you should actually define the task. And I quote, effective task definition is often more important than model selection. That's what CrewAI says in its documentation. Okay. I'd say yes, absolutely. You need to have full illustration. You need to have a full view of the workflows that you're executing. Absolutely. But when you're trying to implement the solution, I I challenge this particular notion. I believe, in my experience of 2 years building LLM applications, when you're deploying LLM agents, at least enterprise level automation or enterprise agents, this advice will put you at risk of invisible failures and brittle systems. In my opinion, and I emphasize that this is my opinion. I say, don't start with the task. Let me go to that relevant slide. Start with your tool design. Only then define the task and choose the model. I want to explain this with the drawbacks of having a task or a flow first approach to building agents. Okay. Let's take the same example. The example here is the use case of building an email processing agent. Okay. Now, the risk here probably differ or could be different for different use cases, but in this particular use case, I believe you, or probably, what I've written here is maybe common to a lot of use cases, right? You have the risk of system-wide failures, because if you're starting with the prompts and not doing a thorough job of defining the tools in details like you would do with your full stack applications before you were writing agent systems, uh, there is a chance that you could probably cascade issues into your workflows that your tools might generate, the untested tools, right? By not starting with the tools, there is a chance that you are rushing into it and essentially building unvalidated tools, basically not thoroughly doing integration tests, load testing, performance testing, and including unit test, correct? uh, you also have complex debugging and maintenance, because the kind of the kind of errors that LLMs generate is out of your control, assuming that you have not done a good job of defining what those tools look like. I'm not saying that these are problems that will always persist, but if you have a very workflow first or a task first and prompt first approach to building agents, these are some of the problems that you can face, right? Poor handling of edge cases. Again, a lot of these probably look very similar because ultimately it's all about how you test it. But I believe that if you don't test those tools, in this case, if you like, let's look at the email classifier, you might have ambiguous inputs, and those ambiguous inputs probably lead to incorrect outputs, and then your workflow breaks for no reason. Um, Obviously, you have scalability challenges as well. If you've not probably done performance test on the tools that you're integrating with, maybe that becomes a bottleneck. And if you have, let's say, hundreds of millions of emails that your agent needs to support, then you've hit the bottleneck. Yes, fundamental system design, fundamental approach to writing production grade agents or systems in general will still be used, but you need to have the tool first mentality to build those robust systems. All right, so excuse me. Now the benefits of tool first approach. Okay, you have deterministic behavior. Tools execute predefined logic, making their behavior predictable and testable. Goes without saying, right? The tool is the only entity in your agent that you fully control, end to end. You control what the input is. You can potentially control what the output is. That means you can always say that if this is the input and this is going to be output, unless and until you have a variable, like a temperature or stock prices in between, but that you will not deviate away completely from the kind of output that you're generating. If it has to be a number, you can ensure that it has to be a number. If your input needs to be a number, you can ensure that the input is number, right? That's the control that you have. That is deterministic. You can obviously, when you have tool first approach, you can think just like how you'd think about reusability in your regular full stack development. You can think of how I can build common tool set for multiple workflows that I'm building. Okay, there are others. I want to the reliability, scalability, and security are something that you can think of. But I want to talk about security, right? Because by building custom tools, you can actually reduce the risks of prompt injection or fragile prompts, right? Because you then control what gets into your tools, and you can also do some evaluation on top of, or validation on top of the responses, and then the context that you're adding as to the LLM, which is the output of your tools, right? You can basically control that. So it's going to be much secure and faster iterations, right? Uh, if you're tool heavy, you can obviously develop the tools and deploy your solutions much faster. All right. I think with that established, I want to quickly go to the the all right. I want to quickly talk about the best practices for tool development. I'm going to just read this through what I've written and then get to the code bit in a bit. To basically build good tools, you need to have very clear specification. Document the tool's purpose, which is the input, output, conditions. Use Pydantic library wherever possible in your input, in your output, to ensure that you have stringent contracts as input as well as output of your systems. Obviously, have logging, enable tracing, write tons of unit tests. Basically, ensure that you're having 100% test coverage, but also think through multiple, all possible edge cases and corner cases. There are some certain, cases that you'll probably, discover in production, but that is fine. But ensure that you're doing a due diligence of covering as much as possible, right? And obviously, your tooling can undergo version control, which is, I think, a great benefit as well, right? Let's say that if you turn that into microservice-based API, you can then version control your endpoints and then introduce changes to your tools in a very structured way. Okay, so with this established, let's actually get to the code. I want to talk about how you can write good tools. I spoke about traces. I spoke about logging. I believe that this is a decent tool set. You probably have multiple. Let me reduce this here. You probably have seen different tool templates in different libraries, but this structure is tool agnostic, or I'm sorry, framework agnostic. You can use this particular tool and still invoke this in. You can use this tool template, in your code, but invoke it in LangChain or LangGraph or CrewAI or OpenAI SDK, agent SDK as well. Okay, in today's example I'll be using OpenAI SDK. What I would very strongly recommend is that ensure that your input and output are Pydantic classes. And this is I'm using the weather API here, and as you can see, I've created an input which is weather input, which is a Pydantic class. And the weather output also is a Pydantic class. What the Pydantic classes allow you to do is write the field descriptions in detail. And this also becomes good context to the LLM when the LLM is essentially leveraging this, the descriptions to essentially identify which tool set and what are the fields, what are the inputs or parameters and arguments that it needs to essentially generate from the given context. In this case, in the example that we spoke about, the email, right? Ensure that you're writing good, clean docstring. As you can see, not just obviously we have descriptions here in the Pydantic class fields, but we also have written docstrings, self-explanatory docstrings, which are written in a way where the human as well as an agent can understand, right? And if you take this example here, we have written a weather tool, and the method here is a fetch weather method, but we have clearly written a docstring of what this particular method does, what are the arguments here, and what does it return, and what exception does it raises in case of an error, and obviously a sample input and output as well. So whether city is equal to Bangalore, output is this, and you should definitely introduce any logger that you can use. There is log guru, or if you're using struct log, you could essentially use that as well. You can use the input logger, anything that you're comfortable with, but ensure that you're logging each and every step of your, or the key steps, both as info or debug or warnings or success logs that you have to. I would also recommend introduce OpenTelemetry tracing for observability. You can use LangFuse as well, which is obviously an open source system. But if you don't have access to LangFuse, you can use simple OpenTelemetry and then either log it to a file, which the way we are doing, or essentially push it to Prometheus and Grafana, right? Depending on what is the infrastructure that you have available. But yeah, this is how it looks like. As you can see, we have in the beginning of the code, we had instantiated the OpenTelemetry library. We've created this file span exporter, basically an exporter of the traces, and we are sending each and every span that we are capturing in our class weather tool class here. And there is clean exception handling here, and every exception is essentially logged. And we are also capturing the right type of exceptions. There is a request exception, there is a validation error, and there is generic exception. We are raising the weather API. We are capturing each and every error that we are or exception that we are getting, and also we are logging them, but also capturing the traces, as you can see. Okay, and we also have a parser to parse the output from the tool API, right? Weather tool API. And the weather tool API is essentially an open API. Let me show you which API we are using. We are using the open weather map, and we're also parsing the response from that and extracting only the fields that we need. And in this case, it is the weather output model. We are extracting temperature, condition, and humidity. We also know what the constraints of those each of the fields are. And we essentially return that parsed output like this using this method. That is, we call the parse weather data method, which is something like this, as you can see. All right. This is the tool. Let's see how the tool works when it is employed. Okay. So here's what I'm going to do. Oh yeah, I have this example. I was testing this. Let me first make a few changes to the tool. What I intend to do is I just want to simulate that I'm not sending the open API, sorry, the open weather API key. Okay, obviously then that means there is going to be an exception and I'll have to work with that. Okay, let's see how we are able to log this particular change. I've written a simple agent. You will get this from the OpenAI SDK. It's the agents SDK. Essentially, you get that in the documentation. It's a very simple example. I am using the python.env to essentially load the environment variables from the .env file. The env example looks something like this. I'm using OpenAI API key and the OpenWeather API key. I will use it appropriately in a bit, but I have removed this just to simulate an exception. Okay, so you've seen the tools.py. I'm going to show you the basic agent.py class. You can see that I have instantiated an agent. Agent is the name is hello world. Again, just a simple example that we copied from the OpenAI examples. The instructions is you're a helpful agent, and we've added this get weather tool. The get weather tools look something like this. It is basically a simple replica of the arguments are the same as our tool that we have created. I have imported the weather tool as well as the input and the output Pydantic classes, as you can see. In OpenAI Agents SDK, we use @function_tool decorator to essentially make that as the tool for an agent, and we then add that that particular tool to the tools parameter in the agent class. Okay, simple. And as you can see, I have a method called getWeather. I take weather input as the input parameter as the argument, which is the weather input Pydantic class, and the output of this particular getWeather method is weather output Pydantic class. I instantiate the weather tool class, and I simply call the fetch weather method by passing the input. Very simple. I'm not passing any doc string here. I'm just trying to debug get weather call, which is fine. And this is the input that I want to send to the agent. Okay, let me first send a simple agent. Sorry, let me first send a simple input. First, let me just send one. Okay, and let's see what happens. I want to delete a few things. You'll probably see that in a bit. These are some of the tests that I've been running, and the logs are being captured. But I was just want to delete those files because the tools.py. Yeah, one thing that I completely forgot to tell. The traces.py. This is the file span exporter. You saw that. Instead of sending it to Prometheus or Grafana or any other observability tool, we are just essentially exporting the traces into a file every time we run or execute our basic agent. Okay, so let me run this basic agent now. Sorry. The OpenAI agents usually take a few seconds to start. And once they start, you should probably see some errors on the screen. All right, so obviously, because we have not been sending the OpenAI, Open Weather API key, we got this error because we have been logging each and every method, fetching weather data, API request failed. The input was Dublin because it rightly identified the input. The LLM identified that the input was Dublin, and it returned this particular message. The API returned this particular message, and the LLM returned this message, or the agent returned this message. I'm currently unable to access the weather information for Dublin. You might want to check a weather website or app. Okay. Now, when you get these kind of errors, you know that obviously the tool is not working. But if you have good good tracing or and observability added, then you should get very detailed logs that look something like this, and which is very important when you're debugging your agent solutions. This is inconclusive, and you don't want to return this as experience to your user, obviously. But if you're debugging, you would want to have every detail of how you have debugged. This is fundamental, guys. I'm not talking about anything new. These are OpenTelemetry logs or traces. You can see that it has captured the exception, and it has done a detailed message and stack trace of the error that we got. This is awesome, right? Now, I was talking about using MCP also here, right? Even if this tool usage we saw here is basically used as a tool in an agentic framework. But let's say that you want to add this to an MCP setup, essentially an MCP SSE server, and then use this in a client, which essentially is calling that particular MCP server, essentially an MCP client, right? Let's see that. So I have this example already written. This is my MCP client. Before that, let me show you the SSE server. The SSE server looks like this. It is a simple server, MCP server we've created with our SSE server. We've instantiated the fast MCP class, and we've used the MCP tool decorator to essentially add this tool as one of the tools that we will be exposing using the SSE protocol. And the method looks very similar to the get weather method in the basic agent. However, this time I'm adding these detailed doc strings here. It will still work without this, but adding this obviously is beneficial. Okay, because it'll not be able to read the doc string from here. It'll consider this to be a tool. It doesn't care how many internal calls that you'll be making, but essentially for MCP, this is the tool, and it is important that you add a detailed doc string of whatever you are returning, you're taking as input and returning as a response. Okay, so this is the arguments. I've just copied it from the fetch weather. I've copied the doc string from the fetch weather method, and we are just running this. So I'm not sure if I'm running this already. Oh, I am. I'm gonna run this server again. Okay. All right, so my server is running, as you can see. Now I go to the MCP client. The MCP client is very simple. We've had several tutorials on this one. I'm going to add the link of that particular tutorial. I'm using OpenAI Agents SDK as the MCP client here, and you can see that I'm calling the SSE server, which is basically localhost 8000/SSE. And the agent looks very similar to what we have called out previously, but here, instead of adding tools, we add the MCP server. We can add multiple servers, as you know, and this particular server, which is basically an SSE server running on port 8000, exposes the get weather tool. Okay, so assistant, the name of the agent is assistant. Use the tools to answer the question is the instruction given to it, And my question to it is, what is the weather in Tokyo? Okay. And let me simply run this. This particular client will essentially make a connection with the SSE server first, and then ask the question. And we should see the response in a few seconds. Yeah, I encountered an issue with the retrieving the weather data for Tokyo. Please try again later or use another source to check weather. Obviously, we've not been sending the Open Weather API. That's why we are getting this issue. But I want you to pay attention to this and why it is important to write these, robust tools with a lot of information. So if you see, this is how a tool object looks like when MCP essentially returns. The MCP client calls the MCP server for to list of tools. This is the list of tools that it gets, and such a detailed message. The name is get weather. The title, we've not added a title here. The description is the doc string. It has the entire doc string, but interestingly, it also captures the input schema really well, which is essentially a Pydantic class called weather input, and it has a property called city. Same goes to the output as well, output schema, properties, temperature. So this is excellent context, very detailed context for an LLM. The LLM can't go wrong here in determining what tool it needs to have, what is the input it needs to create by the information, the natural language information that it has received from the user, and after the output is generated, what does it need to parse essentially to return the relevant response. All right. So yeah, because we got this error, we probably have the traces. Let me go back to the trace. Obviously, the trace looks very similar to that here. I think oh, this is the one. I'm sorry. Yeah, this is the one. For some reason, when I run the MCP tool, the traces get generated here instead of the main directory or the root directory. Interestingly, but yeah, this is the traces look very similar to obviously what we have generated by running the basic agent. Okay, so I hope this was helpful. This is something this is important to essentially ensure that you have a solid mechanism to debug your tools, and you're adding as much context as possible by writing very detailed docstring using Pydantic classes to essentially let the LLM know that this is the input and the input requires such and such fields, and the output has so and so fields, and it needs to essentially uh, parse and generate the relevant, essentially call the relevant tool and generate the relevant response. Okay, uh, I want to go back to the basic agent and run this query, and I want to show you why it is important. I think I'll probably replace this in its entirety. I want to show you why it is important that the LLM knows what is the kind of input that it needs to send it to its tools. Okay, the detailed context that should be given to the LLM about the tools. Okay, so I want to go to tools.py and also enable the environment variable so that now we are able to pass the OpenWeather map API key. Let me clear screen here. Okay, so what we are asking it to do is the agent to essentially get the weather of so many cities in a single prompt. Okay, now can the tool handle so many prompts? No, we know that it can only take one city at a time. But let's see what the agent does. And I think this is almost all agents do this today, but let's see if the agent knows that it needs to essentially, it can make only one call at a time, but let's see if it makes multiple calls and returns the response that we seek. Okay, so I'm gonna save the tools.py, the changes for the changes that we just made, and I'm gonna run this now, basic agent. All right, it's gonna take a few seconds to start. Wow. Okay, so you saw that it has made so many calls in parallel because it knows that the tool can only take one input at any given time, and we are seeing, because we've logged these in the tool, we are getting this input and output logs beautifully. And this is the response from the LLM. Dublin is 13.1 degree Celsius, and the last one, Hospate, is 27.2 degrees Celsius. This is awesome. All right, so this is why it is important to essentially write clean, robust tools and have the tool first mindset, so that provide as much context to the LLM as possible. You have stable systems, you have easily debuggable systems if anything goes wrong. And no agent is perfect. The agents can go wrong, but you want to control the parts that you can control and control them well, which is the tools. Okay, so let me go back to the slide and let's quickly summarize what we just saw. Have clear specifications. We spoke about having Pydantic classes as input and output if you're using Python essentially. Implement comprehensive logging, enable tracing. I think this is key for observability. Handle errors gracefully, write unit tests, have achieved near 100% test coverage. I don't think 100% is required, maybe 90-95% depending on the context, but ensure that you're covering as much edge cases and corner cases as possible. Validate your input and output, and obviously optimize for performance. Don't become, for high frequency tasks, let your tool not become a bottleneck. All right, guys, this is what I wanted to share, the tool first approach to building stable, reliable agents. I know this was a very simple example, but if you extrapolate this to multiple use cases, you'll probably see that this pattern emerges. If you follow the fundamentals, if you build solid tools, then you can build reliable, dependable agents. Okay. All right. If you haven't subscribed already to the channel, please do subscribe. Please share this with your network. And if you found this useful, give a shout out in the comment section. Thank you so much. Have a wonderful day.